So the sheet titled Limits All Within Your Reach. So, part 1, limit x squared minus 2x minus 3 by x squared minus 4x plus 3 as x tends to 3, right? As x tends to 3 is what? You will factorize this. You will factorize this. This will be x minus 3 into x plus 1, right? This is going to be x minus 3 into x minus 1 as x tends to 3. Yes or no? X minus 3 will get cancelled and it will be 2, right? Problem. Limit 1 by x minus 2 minus 2 into 2x minus 3 divided by x cubed minus 3x squared plus 2x as x tends to 2. Clear? This is going to be limit 1 by x minus 2 minus twice 2x minus 3. If you took x common from this expression, denominator, this will be x into x squared minus 3x plus 2, which is x into x minus 2 into x minus 1. X into, right? So this becomes x into x minus 2 into x minus 1. Clear? As x tends to 2, which would be limit x into x minus 1 minus 2 into 2x minus 3 divided by x into x minus 1 into x minus 2, right? As x tends to 2, this would be limit x squared minus 5x plus 6 divided by x into x minus 1 into x minus 2 as x tends to 2, which is limit x minus 3 into x minus 2 divided by x into x minus 1 into x minus 2 as x tends to 2 minus 1 by 2 minus 1 by 2. Right? I mean, I'm assuming all of you would have got all of this right independently as well. Can I move on? Four minus root 15x plus 1 divided by 2 minus root 3x plus 1 as x tends to 1, right? Obviously, you're going to rationalize numerator and denominator. So if you rationalize this, 16 minus 1, so 15 into 1 minus x. If you rationalize this, 3 into 1 minus x, and then of course 2 plus root 3x plus 1 into 4 plus root 15x plus 1. Yes or no? As x tends to 1. Make sense to all of you? Then this will become 5 and put x equal to 1, etc. You'll be able to obtain this limit. Clear? What does this turn out? The answer given is 5 by 2, right? So this turns out to be 5 by 2. Let's move on to number 4. All's good? Limit 1 minus sine x to power 1 by 3 divided by 1 minus sine x to power 2 by 3 as x tends to pi by 2. Clear? Now as x tends to pi by 2, sine x tends to 1. So if you took sine x as some t, then this will become limit t tends to 1, t to power 1/3 minus 1 divided by t to power 2/3 minus 1, right? Now if you recall a result from the previous class, limit t to power n minus 1 by t minus 1 as t tends to 1 is n. Did I tell you this? 1 by t to power, yeah, you can factorize this also. So you could have written this as 1 by t to power 1 by 3 plus 1 a square minus b square, t tends to 1, and that will make it half, right? Clear? So in case, you know, this was, say, sine x to power 5 by 3, suppose this was sine x to power 5 by 3, then what you could have done is this to power 5 by 3, 5 by 3, this is what you could have done. No, not this. This, then numerator could have been divided by t minus 1, denominator could have been divided by t minus 1, and then you could have applied t to power n minus 1 by t minus 1 is 1/3 divided by 5 by 3. That would have made it 1 by 5. All n, I told you that. Even though I proved it for n to be a natural number, it's true for all n. This of course you can write as 1 plus x power n minus 1 by 1 plus x minus 1 as 1 plus x tends to 1. As x tends to 0, 1 plus x tends to 1. So this is like limit t to power n minus 1 by t minus 1 as t tends to 1, where 1 plus x is chosen as t. That makes it n. Right? Limit x tends to 0. Yeah, for the sake of having the sheet documented, I'll still do it. X tends to 0. We just did this a little while ago. Sine x into, yeah, sine x into 1 minus cos x into x into 1 by cos x as x tends to 0. Right? 1 minus cos x you can write as 2 sine squared x by 2. X squared, this as x by 2 squared, balancing this 4 into 1 by cos x. As x tends to 0, this would be 1, this would be half, this would be 1, that makes it half, right? Okay, let's look at the next one. Shall we proceed? Limit 1 plus 2 by x whole to power x as x tends to infinity. Hey, this is 1 to power infinity form. This is 1 to power infinity form, right? So I could have written this as e power limit this minus 1, that is 2 by x, into gx, which is x, as x tends to infinity. So that makes it e squared. That makes it e squared. Limit e power x minus e cubed by x minus 3 as x tends to 3. You want to take e cube common from the numerator? Then this will become e power x minus 3 minus 1 by x minus 3. As x tends to 3, x minus 3 tends to 0. So e power something minus 1 by something, as something tends to 0, that's going to be 1, leaving you with e cubed. Right? X, e power x minus 1 by 1 minus cos x as x tends to 0, as x tends to 0, right? Simple. This could be written as e power x minus 1 by x. I bring in this x, so this will become x squared into 1 by 1 minus cos x, which is 2 sine squared x by 2, x squared. That x squared which was appearing here, I've brought in here, and then this I write as x by 2 whole squared into 4 as x tends to 0. So this would be 1, this would be half, so this will become 2, right? So far so good, right? Number 10. Limit 5 to power x minus 9 to power x by x as x tends to 0. This is limit 5 to power x minus 1 minus 9 to power x minus 1, right? Divided by x as x tends to 0. This would be ln 5, ln 9, ln 5 minus ln 9, ln 5 by 9, right? Very simple. Shall we proceed? Limit x tends to 0 sine pi cos squared x divided by x squared, right? Now sine theta is sine pi minus theta, so this can be written as limit x tends to 0 sine pi minus theta, that means pi minus pi cos squared x, right, divided by x squared. Now what I can do is sine squared, which is sine pi sine squared x, oh sorry, no, sine pi minus theta I have written, sine pi minus pi cos squared x. Yes or no? Right? So what would this be? Sine pi sine squared x sine pi sine squared x divided by pi sine squared x. You know why? Because as x tends to 0, pi sine squared x would tend to 0, so sine theta by theta, and then pi sine squared x I balance, and this x squared was already sitting there neatly, right? So sine theta by theta, as theta tends to 0, this is going to be 1, this is going to be 1 sine x by x whole squared, so that makes it pi. Limit root 1 minus root sine 2x by pi minus 4x as x tends to pi by 4. What will I do? First thing, rationalize, right? So if I rationalize this, then I have root 1 minus sine 2x divided by pi minus 4x root 1 plus root sine 2x as x tends to pi by 4, right? Yes or no? Is there a problem? Right? See, now look at this 1 minus sine 2x. This is sin x minus cos x whole square. Yes or no? What is root 1 minus sine 2x? Yes, not sin x minus cos x, but mod sin x minus cos x. Mod sin x minus cos x, which is root 2 mod sin x minus pi by 4. Yes or no? Root 2 mod sin x minus pi by 4. I take 4 common from this and also minus common from this. 4. So x minus pi by 4, sin theta by theta kind of thing, and then root 1 plus root sin 2x, x tends to pi by 4. Clear? Now to dispense away the modulus, I will have to take x tends to pi by 4 from the greater than pi by 4 side and less than pi by 4 side, right? Let me take the right hand limit. Limit x tends to pi by 4 from the greater than pi by 4 side. Minus root 2 by 4. Now, when x is slightly greater than pi by 4, x minus pi by 4 is positive. Sin x minus pi by 4 is positive. Mod sin x minus pi by 4 will simply be sin x minus pi by 4. Clear? So then this becomes sin theta by theta as theta tends to 0, 1, and this will become sin 90. So 1 plus 1, 2, root 2 will get cancelled. So minus 1 by 4 is the right hand limit. Minus 1 by 4 is the right hand limit. Yes or no? Now the left hand limit. Limit x tends to pi by 4 from the less than pi by 4 side. Minus root 2 by pi by 4. Now when x is slightly less than pi by 4, x minus pi by 4 is negative. Sine of this is negative, so mod sin theta would be minus sin theta, because sin theta would be negative here. So mod sin theta would be minus sin theta. Minus sin theta, so this minus will go away. Sin x minus pi by 4 by x minus pi by 4 root 1 plus root sin 2x. And everything remains the same, only the sign is changed, is 1 by 4. So right hand limit at pi by 4 is minus 1 by 4, left hand limit is plus 1 by 4. So the limit does not exist. Limit x tends to pi by 4, 1 minus tan x by 1 minus root 2 sin x. What will I do with this? No, I will not rationalize this. Sorry? Yeah, right. Someday, what I'll do is, instead of rationalizing, I'll take pi by 4 plus h as x. So, as x tends to pi by 4, h will tend to 0. As x tends to pi by 4, or what you said is also fine, dividing by 1 plus tan x, so tan pi by 4 minus x, pi by 4 minus x will automatically emerge as a subject, which is what will transpire effectively when you perform this transformation from x to h. As x tends to pi by 4, h tends to 0. My new subject of the limit is h, right? So this will then be limit h tends to 0, 1 minus tan pi by 4 plus h. So I'll just write tan a plus b. So 1 plus tan h by 1 minus tan h, right? I hope all of you understand whatever I've done here. Tan this is 1 plus tan h by 1 minus tan h divided by 1 minus root 2 sin x. Sin x is pi by 4 plus h. right? And this is root 2 sin h plus cos h. Yes or no? 1 by root 2 sin h plus cos h is what this will become. See, sin pi by 4 cos h plus sin h cos pi by 4. So sin pi by 4 and cos pi by 4 are both equal to 1 by root 2, and that will get cancelled with root 2. So this will be simply sin h plus cos h. Yes or no? Root 2 sin pi by 4 plus h will simply be sin h plus cos h. Clear? What will you do next? 1 minus cos h is 2 sin squared h by 2, and sin h is 2 sin h by 2 cos h by 2. Yes or no? This 1 minus cos h I can write as 2 sin squared h by 2. Sin h I can write as 2 sin h by 2 cos h by 2. Right? And I can take 2 sin h by 2 common, and I'll be left with sin h by 2 minus cos h by 2. Right? This is what I'll be left with. And this tan h, again I can write as sin h by cos h. Limit as h tends to 0. Yes or no? And this sin h I can write as 2 sin h by 2 cos h by 2. And this I replace by this expression. Right. So as h tends to 0, now this will get cancelled. 2 ठीक है. And then all that you have to do is now put h equal to 0 throughout. So this will become minus 2, this will become 1, 1, and this will become minus 1, etc. Now just plug in h equal to 0 in the expression to get the right answer. Yes or no? Right? The devil here was something that was making both numerator denominator 0. Sin h by 2, sin h by 2. I could factor it out and dispense it away. Right? As x sin inverse sec x as x tends to 0. Now listen to me carefully. Now there is a small little catch here. I know you would be so tempted to do certain things. See, when x is slightly greater than 0, sec x will be greater than 1, yes or no? And sin inverse, a number greater than 1, does not exist. That means to the right of 0, this function doesn't have a neighborhood. Yes or no? Same when x is slightly less than 0, sec x will be greater than 1, and sin inverse sec x will not be defined. Therefore, on either side of x equal to 0, in the proximity of x equal to 0, you have a Chinese mustache. Right? The neighborhood in the proximity of x equal to 0 does not exist. If there isn't a neighborhood, damn thing, how will you find the limit? You have to come closer and closer to 0 from the proximity of x equal to 0, but the proximity does not exist. So, in absence of a neighborhood, the limit ceases to exist. So, DNE. In the neighborhood of x equal to 0, sin inverse sec x is not defined. Right? Shall we proceed? Limit x tends to 1, 1 minus x plus box of x minus 1 plus box of 1 minus x as x tends to 1. I'll look at x coming closer and closer to 1 from the region to the right of 1 and x coming closer and closer to 1 from the region to the left of 1. Yes or no? Right? Now, let me look at limit of this function as x comes closer and closer to 1 from the region to the right of x equal to 1. From the region to the right of x equal to 1. X is slightly greater than 1. Now, when x is slightly greater than 1, this x minus 1 will lie in the interval 0 to 1. To the immediate right of x equal to 1, x minus 1 for all values of x lies between 0 and 1. So, box of this will not tend to 0 but will be identically 0. To the immediate right of x equal to 1, box of x minus 1 will not tend to a value. It will be identically 0. Identically 0. So, then 1 minus x plus whatever is identically 0, you can independently plug in that value. Right? Now, when x is slightly greater than 1, this will be less than 0 but greater than minus 1. And therefore, box of this will be identically minus 1. Will be identically minus 1. Yes or no? So, as x tends to 1, this will tend to minus 1. This will tend to minus 1. That's a right hand limit at x equal to 1. Let's obtain the left hand limit at 1. So far so good. Have you all registered this? No? Limit x tends to 1 from the less than 1 side. 1 minus x now plus. When x is slightly less than 1, x minus 1 is negative but greater than minus 1. So, box of this will be identically minus 1. This 1 minus x will lie in the interval 0 to 1. So, it will be identically 0. Clear? So, as x tends to 1, this will tend to minus 1 once again. This will tend to minus 1 once again. So, the limit is minus 1. The limit is minus 1. Right? (16) x power k equal to 1 to 100 minus 100 divided by x minus 1 limit as x tends to 1. Now, what I could do here is, I could write this as x plus x squared plus x cube plus x power 100 minus 100 divided by x minus 1 as x tends to 1. Clear? This could be written as, this 100 could be broken down into 100 ones and each one of them could be clubbed with these x's, right? So, this will become x minus 1 by x minus 1, x square minus 1 by x minus 1, x cube minus 1 by x minus 1, x power 100 minus 1 by x minus 1 as x tends to 1. What do you say? And I told you x power n minus 1 by x minus 1 as x tends to 1 will be n. Will be n. So, this will be like 1 plus 2 plus 3 plus 100. Sum of the first 100 natural numbers, 100 into 101 by 2, which is 5050. Right? Shall we proceed? Limit x tends to 2 sine of e power x minus 2 minus 1 divided by ln x minus 1 as x tends to 2, right? As x tends to 2, this tends to 0, 1 minus 1. So e power x minus 2 minus 1, I balance here. I have to bring in e power x minus 2 minus 1 there also, right? Now this x minus 1 I can write as 1 plus x minus 2, right? X minus 2 tends to 0, so it is ln 1 plus something. So I should have x minus 2, and then I should balance it with the x minus 2 here. As x tends to 2, what do you say? So now sine theta by theta, theta tends to 1, that's 1. E power something minus 1 by something as something tends to 0 is 1. Ln 1 plus something by something as something tends to 0 is 1. So 1, have fun. Limit n tending to infinity minus 3n plus minus 1 to power n by 4n minus minus 1 to power n. See, in this case, I'll look at two possibilities. N is even and tending to infinity, n is odd and tending to infinity. Essentially, this is what I mean. See, n could be of the form 2k and k tends to infinity, or n could be of the form 2k plus 1 and odd and k tends to infinity. In both cases, n will tend to infinity, yes or no? Now, when n is even, then this limit turns out to be limit n tending to infinity minus 3n. This will become plus 1 when n is even, divided by 4n minus, this will also be plus 1. Yes or no? Right? And now you divide by n, both numerator, denominator. So limit minus 3 plus 1 by n by 4 minus 1 by n as n tends to infinity. That makes it minus 3 by 4. When n is even. When n is odd, in this case, limit will exist if n even and n odd give me the same value. In this case, will they give me the same value? Yes. Because if I look at when n is odd, minus 3n plus, this will become minus 1 divided by 4n plus 1 as n tends to infinity. Again, if you divide by n, you will still get minus 3 by 4. So which is all right. So limit is minus 3 by 4. Can I wipe this off? Limit n tending to infinity 5 to power n plus 1 plus 3 to power n minus 2 to power 2n divided by 5 to power n plus 2 to power n plus 3 to power 2n plus 3. If I divide by 5 to power n, both sides, both numerator, denominator, Hmm? Yes or no? Hmm? So far so good? Now realize that as n tends to infinity, 3 by 5 is less than 1. So if you raise it to a larger and larger power, it will come closer and closer to 0. 4 by 5 whole to power n will come closer and closer to 0. Yes or no? 2 by 5 whole to power n will come closer and closer to 0. Right? But what happens to 9 by 5? It will tend to infinity as n tends to infinity, because this is greater than 1, raised to a larger and larger power, it will become larger and larger, which means as n becomes larger and larger, denominator becomes larger and larger, and therefore this will tend to 0. This will tend to 0 because this will become larger and larger, this will tend to 0. We want to find limit f0 as n tends to infinity. Now, what is f0? f0 is 1 by lambda into 1 by lambda plus 1. Kaam khatam. Where lambda runs from 1 to n as n tends to infinity. Clear? So, this is limit n tends to infinity. This is telescopic, right? This is summation of 1 by lambda minus 1 by lambda plus 1. Lambda equal to 1 to n. How about it? So this is limit n tends to infinity. 1 minus half plus half minus 1/3. 1 by n minus 1 by n plus 1. Right? And then, do you realize that there are only two residual terms, 1 and n plus 1? 1 and n plus 1 are the only two residual terms. So this is limit 1 minus 1 by n plus 1 as n tends to infinity. That makes it 1, because this will tend to 0. Stand by.